Hi guys, today we're going to solve this problem that is the largest subarray with zero sum, and I think it's the day fourth problem of from Striver SDE sheet. So this is an easy problem, and it's a GFG problem basically, and it's a pretty famous problem as well. So let's see. So we are given an array, both having both positive and negative integers. So positive and negative integers. The task is to compute the length. Okay, we need to compute the length of the largest subarray with sum 0, right? So first of all, let's see, by positive integers it can be 1 2 3 4 and so on, the positive numbers or the integers, and by negative integers, that basically 0 -1 -2 -3 and all those negative integers. And now we have to compute the length. Okay, so length means the size of the subarray, and by subarray I mean if we have, let's say, a b c d e f, subarray is the array in the main array itself. So this is also a subarray. The only one element is also a subarray, and this is also a subarray, and this is also a subarray. It can be any subarray, but the condition is that elements or their index has to be consecutive. So if this is 0 1 2 3 4 5, then this subarray, let's say 1 2 3, this is a valid subarray, but this 1 2 and not taking 4 but 5, so 1 2 3 and 5, these are the indexes. This is not a subarray, although it would be said as a subsequence but not a subarray, right? So this is a thing which we need to take care of. Other than that, I think we are done. And now we have to compute or observe all the subarrays that have 0 as their sum. So for example, if b plus c, this is a subarray and the sum is 0, then this is a valid subarray and we need to compute its length, and the length will come out to be 2, and we will say that this could be like a candidate answer or a potential answer. Although we need to compute all the subarrays which have 0 sum in a main subarray, and check for the maximum length subarray. Let's see with an example. So yeah, now for example, we have this subarray, and yeah, that is 15, other one is -2, then 2, then -8, then 1 7 10 and 23, right? This is a subarray and their indexes are 0 1 2 3 4 5 6 and 7, and these are 8 elements, that's why the last index is 7. So yeah, it's fine. Now we need to compute which is the now we need to compute the maximum length subarray with having some 0. For that, we are not going to be bothered by the maximum length, we are only going to be bothered by subarray which has some 0. Let's see, let's carve them out. So this subarray has the sum as 0 because -2 plus 2 will be 0, and this subarray will also have the sum as 0 because -8 then +1 will be -7, and -7 plus 7 will be 0, and this subarray is also 0 because -2 plus 2, that is 0, then -8 plus 1, that is 7, and then -7, and -7 plus 7 will be 0. So its length is 2, this subarray length is 3, and this array subarray length is 5. And now we have 2 3 and 5. We need to pick the maximum length and we will be returning that length, which is shown in this test case that we are returning the 5. So now I think the question would be now clear, and you can see that this is the subarray which we have chosen for the maximum length, that is 5. Now let's talk about the approaches for this question. The first approach would be the naive approach or a brute force, and a brute force approach is very simple for this question, because if we have this subarray, let's say, right, so if we have this subarray, and now you know what, now let's implement a pointer I, and from this I pointer, now let's implement a pointer I, and from this I pointer I will have a j pointer, and j will be implemented from here. Now I'm going to uh, calculate all the subarrays which have the sum as 0. So from 0, that is the I, from I to I plus 1, I plus 3, up to the way till the last element of the array, and we are going to calculate all the subarrays. For that we will be using a nesting loop, and in nesting loop we will be checking if the, and let's say for this example the I value is 0, right, and j value is I plus 1, or you know what, 0 as well, because 15 could also be counted as a subarray and is 0. Now one subarray that we will get is 15. Another subarray when the j is incremented to this part, so now this subarray is acting like this one, and the sum is 15 minus 2, that is 13, and then j is incremented here, and now this is a subarray, and now the length is going to be 15 again, and then j is going to be incremented to this point, and this is a subarray, and now the length is 7, and now j is going to be incremented to this point, and this is the subarray, and length is going to be 7 plus 7, that is 14, right. This is how we're going to move, and I can tell you that with 15 having as the first element of a subarray, we are not going to find any element, and or we are not going to find any subarray that is resulting in the 0 sum, which is why I'm going to increment my I pointer. So I have exhausted all the subarrays and looked for all the subarrays which are starting from 15, and now I'll be starting my I pointer from -2, and from -2 this is the first line, right. This is the, and none of them is 0, so we can just simply remove them. Now j pointer is now first of all pointing on this one, so this is -2. Now j pointer is pointing on this one, right, so now this is 0. Okay, so we have found 0, and when we have found 0, we are going to have a length variable which is equal to max of length comma j minus of I, right. Now j minus I is 2 minus 1, so its length is going to be now j minus of I, and j minus of I is going to be 2 minus of 1, which is going to give us 1 as the length, but 1 is not the length, so which is why we have to j minus I plus 1 as the length of the subarray. And initially the length could be initialized to minimum value, initially it could be initialized to int minimum value, and now we are going to have the length, so this is the part, and now the length is going to be 2, right. Now let's say now we have initialized the, so this is the I, and now we have initialized the j pointer to this one, and the subarray, so it was -2 0, and this is the part where we have stored the length as 2, right, and now we have this subarray, so this subarray is going to have the sum as -8, which is not 0, so we are not going to be bothered by that, and this subarray is going to be this one, and this is also not because this is -7, and when we move to this part, then we realize that this is also 0, right, because the sum for these elements, this subarray is going to be 0, and if this is 0, then we will compute the length again, and now to compute the length, the formula will be 5, that is the j minus of I, that is 1 plus 1, and it will came out to be 5. So we are going to store that we have 5 at this index, at this, for this subarray, and then similarly we will take this process and keep on repeating it till we have our I pointer and j pointer, till we have our till we have our I pointer and j pointer at the end of the array, that is it's pointing on the nth element, which is not there obviously, nth index, that is the size of the array. And after this process, the length, because it's set to be in such, is set such a way that we are containing, every time we are storing the maximum occurrence of length variable, and we will be successfully getting out of the loops, of the nested loops, with the maximum length. Now if we talk about the time complexity for this solution, it will obviously be n square, because we are using two nested loops, and the space complexity. Now, space complexity will be constant. Why? Because we are not using any auxiliary array, map, or set, or anything. We are just using two variables. One could be the sum variable, and another could be the just length variable, and that's it. And that's like a constant space. So this is the first approach. Now we obviously want to see, like the second approach. So the second approach will be using a hash map. Using a hash map, and it is an optimal approach. So let's see how we can do this. So for this we have our array as yeah. So now what I'm going to do is I'm going to use an hash map data structure, and let's say this is our hash map, right? And yeah, so first of all I'm going to give you the algorithm and how we are going to use this algorithm, and then you may be able to recollect the pieces and try to implement it on your own, and it will make sense, I believe. So that it will make sense at the last. So we are at first, I is pointing on the first element, right? And at this place we are going to store that at this place we have the sum as 15, and at 15 we have the index as, we're going to store the index, corresponding index which we have got, and that is the 0th index. And when we increment I to next pointer, the sum is going to be 13, and we are going to store the index that is first. And when we increment I to another pointer, and now we have 15 again, and 15 is at, well, this is the part where I want you to see something, that if we have calculated a sub, if we have calculated or seen a sum at previous position, and now we are again at that position, then at previous position to the new position, these elements have not contributed in anything, right? Because these elements have not contributed in the final sum, in the sum at this place. So this, from this place to this place, these elements, the length of this sub array basically is whatever the length is, the sum is basically 0. That's the whole catch of this thing. And if we want to collect, if we, so now I'm going to see that is 15 in the list in the hash map. Yes, it is. So now my length variable, which was initially nothing, and now it will be initialized to something, and that something will be I minus the value of the previous sum, that is 0, and that will be 2, right? So now I'm going to start my now I'm going to increment my I pointer to this place, and my sum is going to be 15 minus 8, that is 7, and 7 the third index, and then I'm going to increment my I pointer here, and I have the sum as 8, and I don't have 8, so I'll be storing it in my hash map, and then I increment my ith pointer again, and now 8 plus 7 is going to be 15, but 15 is present here, which means that from this point, that is the 0th index, to this point, that is I'm on currently, that is ith index, these elements have not contributed in anything, which means that this subarray is giving me the sum as 0. And to get the length, what I will do is, now the length for them will be I minus of the previous element, that is 5 minus of 0, and it is greater than the previous length, so I will be storing 5 here. And now I will increment I is pointing on this element, and the sum is 15 plus 10, that is 25, which is going to be 6th index, and now I will be incrementing I, and that is 48. And because these index are not, these sums are not present in the hash map, so we are not going to compute anything, and we will be ending up with the maximum length, that is 5. So I believe that this approach is clear. Pretty minimalist question. Now let's see how the code is executed. So first of all, we need to have a length variable, right? This is, I think, first of all we need to have a length variable, then we need to have a sum variable, because that sum will be used to store the sum in the, because that sum variable is going to be used in storing the sums in the hash map. And then obviously we will have a hash map, and in C++ I have used an unordered map because the because the insertion as well as the search is constant time. So this is a sum track hash map, and now then I'll be calculating the sum. So this is a very important line. So if we have our sum as 0, let's say that we have an array like 1 minus 1 2 minus 2 3 minus 3, right? And at this position I calculate that my sum is 0, then I will say that the length is from the beginning, right? So if I'm at 0 1 2 3 4 5, so if I'm at first index, then my length is going to be 2. And if I am at this position, my sum is again 0. So I will say that from the beginning to this point, the length, this subarray has the length as 0. And now the length is going to be 3, that is I plus 1, that is 3 plus 1, that is 4. And similarly for this case as well, if I'm at this position, the sum is again 0, and this, which means that this subarray from the beginning is 0, and it will be I plus 1, that is 5 plus 1, and that is 6. Right, so this is the point which signifies that if we encounter our sum to be 0 in the array, then we will say that from the beginning to this point, to the from the 0 to ith point index, these elements result in 0 sum. And if we want to get their length, then I will simply just say I plus 1, right? And then this thing where we are, and then this line computes this process where we are checking that if we have this sum already stored in our hash map or not. Because if we have this sum already in our hash map, then we are not going to compute, or we are not going to store it again. We will just say that the elements till this point to the hash map which we have, to the place where we have stored the hash map, this place, they are giving us sum as 0. So now we can simply calculate the length, and length will be maximum of the previous length or the new length, that is I minus sum track, or the value that I am getting from the previous element, and this will be the length. Otherwise, if it is not present in the in the hash map, the sum is not present in the hash map, then I will simply just store it. And after this whole process, presumably I will have the length which is maximum and of the subarray, which gives me the 0 as a sum. And if we talk about the time complexity of this solution, the time complexity will be linear. Why? Because we are just using this simple for loop, and it's traversing on the array elements. And if we talk about the space complexity, then space complexity is going to be linear as well, because we are using an hash map, that is a linear space complexity. I mean, in average case, it's a linear complexity. Otherwise, in best case, where we have our 0, then it will be just a constant time. So this is like I think the most optimized approach. There can be another approaches as well with using some advanced data structures, but they will be very much close to linear time complexity or space complexity. So yeah, that's it, guys, and thanks for watching.